Hello everyone, welcome back to my channel. The previous video we had discussed about symbols, and in this video we are going to discuss about valency, and we'll try and understand what valency is, where it is used, how is it determined, and so on. First of all, let us start with what valency is. Right? If you can see what I have written here, valency is something called as combining capacity. What does this mean? In chemistry, we discuss about, or we generally study about atoms interacting with other different atoms, correct? So, whenever an atom interacts, now what do you mean by interacting? Interacting means when it is making a bond, chemical bond, right? So, when it is making a bond, how many bonds is it making? How many bonds does a particular atom make? That is what is called combining capacity, right? For example, if you know the structure of water molecule, it is somewhat like this. Water molecule is made up of two hydrogen atoms and one oxygen atom, correct? Here, you can see that one single hydrogen atom is making one bond with oxygen. So, what's the valency of hydrogen here? The valency of hydrogen atom, which is represented as H, is 1. What's the valency of it? It is 1. Okay. Similarly, if you can see oxygen also, there is another element oxygen here, right? How many bonds is it making? It is making two bonds, right? So that will be the valency of oxygen, which is 2. Let me give you another example. There is a molecule called as methane, which is CH4. This is how it can be written. This is not the exact structure of it, but for now, you can write it like this. Like I said earlier, hydrogen has the valency 1. That means it is always going to make one bond. So if you can see, all 4 different hydrogen atoms are making single bond, correct? Whereas the carbon which is in the center is making 4 bonds. What does this say? This suggests that the carbon's valency is 4. This is what is called valency, right? This is how I have written in simple terms. It's just combining capacity of an atom. But if you want a little bit more detail, in the sense, I have just told you that the valency of hydrogen is 1, oxygen is 2, carbon is 4. How do you try determining it? Correct? For that, we can answer it from this. I hope it's visible, and if you can read it out, it says number of electrons an atom gains, loses, or shares. Excuse me. Correct? An atom can either gain electron, donate electron, or give electron to some other atom, or the electrons can be shared. How is that going to happen? That might be discussed in another video about chemical bonding. But this is it, right? So if an atom, let some, for example, here I have mentioned that metals generally have positive valency, right? And non-metals have negative valency. Why is that? Here I'll take an example of a metal like sodium. I hope you remember the symbol of sodium, which was probably discussed in the previous video. Sodium is written as Na, capital letter N, that is N in uppercase and A in lowercase. Now, what is the atomic number of this? It is 11, which is written here on the left hand side subscript. Okay. What does this atomic number suggest? What does atomic number tell about a particular atom? it tells you how many protons it has. Now, what are protons? Protons are positively charged particles. Not only that, you should also know if an atom is neutral like this, the number of protons will be equal to the number of electrons. That means this atom, sodium, whose atomic number is 11, which has got 11 protons, will also have 11 electrons. Correct? And how are these electrons distributed in the sodium atom? It can be written like this: 2, 8, and 1. What does this mean? It means that there are 2 electrons in the first shell, 8 electrons in the second shell, and 1 electron in the third shell. Okay. You should also know about a rule of something called octet rule. Okay. Octet rule talks about the stability of an atom. This basically helps us try and understand excuse me, the stability of an atom, if an atom is really stable or not. How will we get to know that? The rule says any atom is stable if its outermost shell is filled with 8 electrons. Now, this is the atom, this is the electronic configuration. Like I said earlier, this is first shell, second shell, and third shell. So this third shell is the outermost shell, apparently. Okay. Now this has got how many electrons? It has got 1 electron. But what does the rule say? Rule says it should have 8. It doesn't have 8. That means it is unstable. So this atom have the tendency to give away that electron, lose an electron. You getting it? So when that atom loses that electron, the configuration is going to be 2, 8. Okay. Now the symbol of sodium, which is again Na, and atomic number remains 11 itself. Now the charge or the valency can be written as plus, Na plus. That is what I have mentioned here. Metals will have the valency that is positive. Why do they have positive valency? Because they have the tendency to lose electron. Why do they want to lose electron? To attain stability according to octet rule. Okay. Similarly, let us take another example and understand about non-metals. Just a second. Okay. So let us talk about a non-metal like chlorine. Chlorine, CHLORINE, whose symbol is capital letter C and small letter L. Okay. Whose atomic number is 17. Now the configuration of this is going to be 2, 8, and 7. Again, octet rule will still be applied here also. What does this mean? Atomic number is 17. That means it has got 17 protons. And of course, this atom is neutral. That means it has got 17 electrons also. Now, where are electrons present in the shell? In the first shell, there are 2 electrons. In the second shell, there are 8 electrons. And in the third shell, there are 7 electrons. Now, it is not stable according to octet rule. So, what will it do? In the previous case, in the sodium, the atom lost an electron. Okay. Whereas here, that chlorine atom will gain an electron. So when it gains that electron, the configuration will turn into 2, 8, and 8. I'll write the symbol as it is, atomic number as it is, but the valency or the charge is going to be minus. Is it clear? Cl minus. Chlorine is a non-metal and excuse me, it has a tendency to gain electron. Whenever it gains electron, it will attain a negative charge. Non-metals will have a negative valency. I hope it's clear. Okay, That's a wrap on valency. I hope whatever I've thought is reaching you people. Uh, if you have liked it, please like the video and share to your friends. And if you have got any queries or questions, please don't forget to comment. And also subscribe to my channel. Thank you.